All right, in this little lesson, we're going to be talking about finding a velocity from acceleration. And so don't forget, so there is a formula associated to this, but remember that if you have acceleration and you do the antiderivative of it, you're creating the velocity. So it's a formula, but I'm going to take a little bit of a different approach, something that I'm already familiar with, and kind of work through it. Now, this question is going to go a little bit bigger than what this is talking about. It says, find the position and velocity of an object moving along a straight line with the given acceleration, initial velocity, and initial position. So let me kind of work through all my steps here. So in order for me to find the velocity function, I can do the antiderivative of the acceleration function. So that would be us doing the antiderivative of negative 32 dt. And so that would be negative 32t. But because we don't have bounds, we'll tack on a plus c. So I'm taking a little bit of a different approach, but I'm going to get the exact same thing. So I'm trying to not create a new formula for something that I've already done and already familiar with. So once I have this, I can use this piece of information that at time 0, my initial velocity is 70. So I can plug in 70, plug in 0, and the only thing missing will be that c. So I can solve for c. So 70 equals c. So my velocity function, based on this given information, is going to be negative 32t. Right, here's my velocity function, plus that 70. So there's my initial velocity. All right, on to the next. So in order to find the position function is going to be the antiderivative of your velocity function. Well, luckily, we just found the velocity function. Here it is. So we're going to be doing the antiderivative of negative 32t plus 70 dt. Okay, so if we do the antiderivative of this, we're taking negative 32. We're going to take the t, add a power, divide by the power, plus 70t. Right, and then technically that's our position function. We are going to clean it up, but we will be tacking on a plus c because we don't have bounds. So this becomes a negative 16t squared plus 70t plus c. That's where we currently are. So now I do have more information to find a very specific c value, just like we did over here, that if I plug in 0 instead of equal to 10, 10 is going to equal negative 16 times 0 squared plus 70 times 0 plus c. So I wipe away those. Basically, I'm going to get a 10 equals c. So our position function, now that we know the c value, is negative 16t squared plus 70t plus our c value of 10. So I'm taking the same approach. I'm not kind of memorizing any formulas. I just know that if I do an antiderivative without bounds, I'm going to have a c. And then if they give me a specific information, I can use that information to come up with a very specific position function and a very specific velocity function.